This is a video to help you with the HVAC assignment for Environmental Systems 2. Here's our site. I am working with this floor plan: gym, outdoor court to the north, lobby, office, 2 lockers, and the mechanic room together. I've turned this into 3 zones, 3 thermal zones: my gym, my my locker, mechanical room, and my office lobby. That's not the way you need to do it. I don't really care. I know this is a lot in 1 week. I just want you to have at least 2 zones in your project. Remember what a thermal zone is. It's just a place, it's a volume of air that we're saying needs a certain amount of heating and cooling. And it's going to be different in a gym, obviously, than in an office. So that's why we're separating these out. The way to create a zone is whatever you've got. Let's say you've got you've got your daylighting design and you've got separate surfaces and however you've laid it out. You've got your windows maybe as punched openings. To make thermal zones, what you want to do is just to make an extrusion. And the way to think about it is that a thermal zone is just a volume of air. So I'm separating out a volume of air with that extrusion. I'm going to add a surface to it so that I can have a window. So now I've got an extrusion and a surface that's coplanar with one of the surfaces in my extrusion. Now I'm in my thermal analysis workflow here. I'm going to select this volume and add a zone. I could give it a name if I want to. I'll say test. Say OK. I'm leaving all that. I'm not thinking about anything else. You see there's a bunch of windows here already. I don't want those. Those were automatically set at a certain window to wall ratio. I'm just going to come back into there and say 0. And now I can take this window that it's an actual window for my project, and add it here as a window. And now I have a thermal zone and a window that has a window just like my thermal zones over here. So that's how you do it. Okay, so now we've got our setup for our project, our thermal zones for our project. What we need to do now, remember what's our goal? We are trying to create an estimate of the amount of energy this building is going to use and how much heating and cooling, our peak heating and cooling loads, the amount of heat and cooling that we need at the highest peak hour of the year, and then use that information to size our mechanical system. So how do we do that? I'm going to come over here to this little library book, click on it. We have, in class, I quickly went over the fact that we have zone space use templates and zone construction templates. We need to define all of the variables in these 2 templates. So the way I want you to do that is to select just any template and come down here and say copy. I think I've already just made one of these. I'm going to say test 1. I give it a name. I say OK. I scroll down. Yeah, that's one I just made a minute ago. So now I can edit this and change the settings. So I'm going to go to one that I already have basically set up. So I'm saying you be editing whatever you created. But now I'm showing you what settings I want you to have as your baseline. So the zone space use settings is setting the amount of heating, or it's defining the stuff that's putting off heat in the building and in this tab. So we have people. Let's not even talk about how many people. Just put that number in there. But the idea is that people give off heat. We're little combustion heaters, right? So we're always giving heat into a space. This metabolic rate has to do with if 1 would be completely stationary, so 1.2 means we're moving around a little bit. Of course, in a gym, it's going to be more than in another space. I'm not worried about it. I want you to set all of your schedules to all on. The idea is that just means that we're not thinking about when people are in the building and just leaving lights on and mechanical systems on and everything on I mean, mechanical systems might turn off because they have a thermostat, but there's no hours of the day that they're told to not be on. So I want you to set all of those schedules to just all on. You can go and turn the hot water on, and you can leave whatever defaults are in here for the hot water. Because, so hot water is going to be putting heat. If you have a hot water tank, it's going to be putting heat into the building. Lighting puts heat into the building. This is the lighting power density in watts per square foot. In other words, that's how many watts of lighting we need per square foot of building. So it's a general number. Same thing, the equipment, all the computers and stuff are giving off heat. So we define how efficient they are with this number. I don't expect you to understand these very, very much, but I want you to put those numbers in. The other tab here is conditioning. This is simply setting a thermostat set point. I'm going to set these both at 65. I don't really care. You could set them to whatever you wanted to. And let's set the mechanical ventilation at these numbers. This is the amount of fresh air that we're moving into the building and out of the building, right? Because we need to breathe. That, of course, when we breathe it, we bring in fresh air from outside, we're going to be losing, whatever we're exchanging it for air inside the building that we've heated or cooled. If we dump some of that out to bring in fresh air, we're going to lose some energy. So that's why we need to know that number. Okay, so we've set a baseline space use template. Now let's do the zone construction template. The same thing here. You're going to just pick one and copy it like we did before. I'm just going to go down to one that I've already copied and show you the settings I want you to have. So we're in the envelope. This is just a bunch of presets for different parts of the building envelopes. This is the roof, and if you look at the little diagrams over here are showing you what part of the building they're calling the roof. And if you click on it, there's a ton of these you can set. You can make your own. What I want you to select first is just default construction, and that means it's going to be pure concrete. So this is, we used to build like this. This is the Guggenheim is just pure concrete. So I want you to set default construction for all of these. For your infiltration, I want you to set it at 0.2. There's two settings here. You can go to air exchanges per hour or flow exterior area. Go to that because we want it in CFM per square foot. If you don't know what that means, don't worry about it. The rest of this you can leave as presets. You can skip the settings tab and go to the exterior window. Whatever windows you have, I want you to start with the default glazing. And so if you click on that, you'll be able to choose default glazing. Okay, so we have set our zone space use and our zone construction. So this is the loads inside. I just described it. Think about it. The construction, that was all stuff that has to do with the physical building that we've designed. Okay, so and the point is you've now created your own templates here. And so now you can come back to your zones. So I'm going to select all three of my zones and click on, I can do space use and construction at the same time. I'm going to click on this button right here. And now I can come in and I can choose my template. So if I click on this library here, sometimes you have to, I don't know why it's always seems to be the office is the preset. So go to this drop down and say any building type. When you do that, if you scroll to the bottom, you'll find your template you just made. So I would select my baseline. That's the one I used. How I set my baseline. That was what I called my baseline template. I'm sorry. And now I'm going to do the same thing again for my construction. Click here. Go in here. Say any building type. Scroll down. I'm looking for my baseline. And so now you will have set your baseline simulation run. Make sure you have this ground setting so that it should be green. If you don't have it, again, you have to create the perimeter of whatever's touching the ground and add it here. It'll show up here, and and it'll turn green. So that's how you know it works. If your windows are working, they'll be blue, and if your zones are working, they'll be white. If you get like a red outline around your windows, that means you don't have it touching coplanar with its surface, so you'll have to fix that. If you're just trying to be down and dirty and you don't have a lot of time, you could just set you can automatically set window to wall ratio. Let's say I'll do it here again. I'll say 0.5. Half of my wall is window, and maybe it didn't work because I've already got. Maybe it's because I didn't. I'm not sure which one that is. It's the lockers. Well, if I didn't already have those set, it would let me do that. I'm not going to worry about that right now. And I don't think you should do that. I'm just saying that's if you're out of time and you can't get your windows to work, you could try that. Okay, so now all I need to do is run it. So I'm going to run it. By the way, when you're running, you should see a DOS window show up. And so here is my initial output, and this is great because it didn't work. The way I know it didn't work is that I don't see a heating and cooling load here. You wouldn't know that. But if you see, if you don't see red and, well, I'll show you in a second. What I know happened here, and I forgot to talk about it, should have automatically set it, but I think it doesn't matter. I also need a mechanical system. So if I click on this mechanical system tab, and by the way, you can ignore this tab. This is just picking energy types and how much they cost and their carbon footprints. You set your zones here. We have a mechanical system tab here. And I don't have my mechanical system applied to any zones. So I'm going to set it for all three of them right now. Oh, I remember why that's true. It's because I was doing something before. There is a thing called an ideal air load default. I'm going to edit it. You can leave these settings as they are. I think the default that I'm asking you. Let's go through this. I'm sorry. We want to have a heating COP of 0.8. I talked about that in class. I want these to be all on. You can have a cooling COP of 3. That's fine. You should ask me about that if you don't remember what it means. For now, we're going to turn the mechanical system on. We're going to have it all on and no ERV chosen and no natural ventilation. Okay, so that's the baseline. And of course, you're pausing this video and stopping and putting these in this whole time, hopefully, these inputs. Okay. So now, if I've got a mechanical system applied to all three zones, now it's going to work. If I go back, and I'm not going to save the other one because it was not correct. It's running. And now I have an output that makes sense. I've got the red is heating load, the blue is cooling load. All these other, and so by the way, I'm on energy flows. The energy flows chart lets me look at things like, so you see the light, this light green is my building envelope, so I can see that there's a place that I can improve. So I've got an initial starting point that I can try to improve. So let me go back to my actual. I'm going to delete that because it's just me. So here's the runs I made. I started with this one, and the first thing I noticed was that my building envelope was pretty bad. So I went in and I changed that I went to what you're supposed to be doing is iterating. I think it says 6 times, and this can go quickly because all we're doing is I'm selecting these both. I'm going to edit my. I just said I want to change the envelope. I'm going to come in here, edit here, go to envelope, and I can come in and change and just select something that I think is going to be better. One thing you could do is just go to the 90.1 non-residential templates, and if you go to CZ4, CZ4 is our climate zone 4, and select it, that will be better for sure. Or just find ways. This is the point of this, is that you're going into this and trying to say, well, what is causing energy loss, and let me try to fix it. So I did that and ran it, and my next oh, this is actually by the way, the reason I don't have the sight on, I don't have my trees or anything, is that it's not going to make much difference. Here's the baseline I ran, and here it is with shading, including buildings. It didn't have any effect, so you can just leave them off, and we can talk about why that's true, but don't worry about it. So now, the next thing I did is I changed, like I just said, I changed my building envelope to a 90.1 standard, and I got a major improvement from here to here, and we can see it's mostly from this light green building envelope section. Next thing I did was I tried to, you see I have like a lot, the darker green is windows. I have a lot of heat gain in the summer. It's not very bad in the winter. I mean, and I would want some more gain in the winter and less losses. Maybe you don't understand this chart. We have to talk about it, but basically, yeah, I realize I don't think I introduced this. Here it is very simply. This is called an energy balance chart. We have every month is balanced, and so we have the same amount of gains as losses, and we have those divided into different components from our building. Like lighting is that little yellow strip. The windows are this darker green. The envelope's the lighter green. And so I can look and see things that I would like to try to improve to get. So I want in the you have to think. I mean, I don't want to get too detailed here, but I want to reduce these as much as I can. Usually, low in the winter, I wouldn't mind having some gains for my windows here. Right, I have a lot of losses, some gains. In the summer, for my windows, I've got a lot of losses and no gains. That's bad, right? Because in the summer is when I want to be. I'm having to cool. That's what the blue is. So the summary is that if you take out the red and the blue, you'll always see that there's some imbalance. Like so, in January we have a lot more losses than we have gains from our windows and our envelope and our lighting and this light color here is people. So we have to heat a lot, right? In the summer we have a lot more gains than losses, so we have to cool a lot. Okay, but anyway, so I went from here where I had a lot of heating, and I improved my envelope, and now I have a lot less heating that I need. And so then the next thing I did was I went in and I improved my glazing, and I dropped my value again even further. So I went from 100 to 85. The way I do glazing is I come in here. If I open up everything, oops, and I select all of my, this is the easiest way of doing it. Select everything, and then I edit a window. I can go, okay, so now it's saying, do you like the envelope? I'm like, yes, that's fine. Now it's going to ask me about the window. I can come in here, select the window, and choose a window that I like. I realize that you may not know that much about these. We've talked about it a little bit, so just do your best. Just try to get an improvement. And if you don't, we can talk about it next week, so don't worry about it too much. But that's how I improved the windows. I selected the window, a better window package. Then I went in and I added schedules. So remember back here where we if I go back to look at one of our oh no, I'll go look at the mechanical system. Oops. If I come in and start adding schedules here and saying I don't want it all on, I want it to be just on during the day, or I could put in a gym and pick a secondary school gym, because I think that's going to give me, see, this is when the everything's running, and then it's off when people aren't there, and then I can change the schedule here and I could do the same thing for cooling. I could do the same thing for mechanical ventilation. I could come in and I could add a, remember that this was the HRV or the ERV. That's going to definitely save me some energy. So this is just an opportunity for you to try to look at the slides that I presented, and then see if you can find ways of improving the energy efficiency of the building by changing things. And so I did that, and I eventually got to here. So I got, because I know what I'm doing, I got it to be pretty low. By the way, this baseline over here, this is a comparison to a building that's sort of normal for whatever type of building I've chosen. You should just ignore that. Just try to get this number as low as you can get it, or at least see it go down. Okay, so now I have this. We're saying this is my optimized run. Let's now look at a few things here. I'm going to go to my energy use intensity. This is just EUI means energy use intensity. It's just how much energy we're using in this case per square foot. And here we can see, if we go back and click through these, we'll see this changing quite a bit, and we're getting more energy efficient, which is what we're trying to do, right? A more useful chart was the energy flows, because using this I can actually see, oh, I want to improve my building envelope. I can do that. And it got better. I want to improve my windows now. They got a lot better. You notice that we have almost no losses in the summer. My mechanical schedule should take this. You can look and see what it changed there. Mainly, it just took down the because we have the machines off less. We just have a lower heating and cooling load. So the red and the blue got smaller. Air infiltration was this here. I changed that value. That dropped way down. Okay, so that's how I already mentioned that. That's how I use the energy flows chart. The other two charts you want to look at in here are the peak heating week and the peak cooling week. What these are telling us is this is the week when we use the most, when we're heating the most, so we have the highest heating load. And so we see here, this is the high. This is our peak load. So here around, sometime around 1.5, sometime during the day of 1.5, we had our peak load, which is about 110 kilobTUs per hour. We also have a peak cooling load, and in this case, it's about, let's say, about 16 or close to 16. So that's what we're just using to design our mechanical system with, because we want our mechanical system to be able to deliver the most heating and cooling that we need. So we need to identify that amount, and that's the peak. But the way we do it to be able to size our ducting is I then went back and I went to my ideal air load mechanical system setting, and I assigned it to each of these individually. Ooh, I screwed up and changed the name, so let me say okay to that and come back to this. You have to be careful. That's because I wasn't thinking, and this is just experimentation. By the way, I don't expect you to be great at this instantly. Yeah, you see how these are all called gym? So let me just go back and figure out. This one is office. I'm going to say lobby. Office. And this one is gym. This one is lockers. So if I come over here and look at my zones again, now they're correctly labeled. So I'm going to start with the gym. And now I can run it. I can run my simulation again. And I did that, and so I was able, by just selecting the mechanical system for each different zone, I get the peak loads for each zone. And these are what I put into my spreadsheet. So I'm going to open up my spreadsheet. This is available in there's a link in the assignment, and then also on Canvas in the resources section. So let me actually do this. First, I'm going to some of this information we need is in our climate summary. Let me see if I can get over to that. So if I'm this little Earth is our climate summary, and I had set the heating degree days for 64. I should have probably set that the same. I can change this now actually. I think it changes it. So I think I said 65 when we were doing the simulation, so I'll change that here. I will put, and that's my set points. So I'm going to say 65 for both heating and cooling. These you can just copy straight from what I'm doing. I also have heating and cooling design temperatures. So the cooling is 19 degrees. This isn't going to change anything, but it's just a holdover from a different version of this spreadsheet, but you may want to put it in. Interesting. That got deleted somehow. Let me just go ahead and fix this really quick. You can ignore this, but you may want to see how this works. I'm saying absolute, and I'm saying this cell minus this cell. And that's just getting us the temperature differential. Anyway, you don't need that, but you do need the set point temperatures. Now, let's go back to our simulation results. I'm tired. So let's start with the peak cooling. Looks like we're around, I'm going to say 10 for the gym, right? So I'm going to go to the gym right here. And this is in tons. I don't remember we talked about that in class. So I'm going to say 10 tons, and I've got it set up to where this automatically generates. It's 12,000 BTUs per ton, so it's 120,000 BTUs of cooling for our peak. I'm going to put in 55 degrees. That's the air temperature that we're going to supply our cooling with. And there's an automated calculation in here that you don't need to worry about that tells us what the CFM requirement we have is. Then I'm going to go to the lobby office. Oh, actually, I also need my heating. So let me spread this out a little bit. I'm going to make my heating temperature 100 degrees. So this is when we heat the air, we're going to heat it to 100 degrees and send it through our ducting. The cooling, we're going to cool to 55 degrees. Okay, so in my office, I have a peak cooling load of 2.5, I'm going to say. And a peak heating load of 16,000, because it's kilobTUs. And for my lockers, I have a peak. Oh, I'm sorry, I didn't do the gym peak cooling. So let me go back to the gym, or the peak heating. I have, looks like, I don't know, 75 maybe, so 75,000. In my lockers, I have peak heating of, I don't know, I'm going to call that 17,000. Oops. And peak cooling of, again, I'm going to say 3 for that. CV55. Okay. So now I have all the peak cooling and heating loads for my 3 zones. So let's just look at this for a second before we move on. What is this telling me? What am I looking for here? So the CFM, remember, is the cubic feet per minute of air we have to move. So if I have a peak cooling load of 36,000 kilobTUs and the air temperature is 55 degrees that I'm moving, I need about 3,300 CFM, cubic feet per minute, of air I'm moving through ducts. Okay, cool. How about in the same zone, I have 17,000 BTUs I have to move for heating. It's at a higher temperature, 100 degrees, so I'm able to move more heat. And so I have a much lower CFM requirement for heating. So all you need to get from this is that if we look back just at our heating degree days and cooling degree days, we obviously have a lot more heating degree days than cooling degree days. But that's not what we're measuring here. We're looking at the peak loads, and since we have other variables like the different temperature, I don't know why I changed that. Let's see now. Somehow I screwed that up. It doesn't matter. Let me just do that right now. Control C, and I'm going to say, yeah, okay. Anyway, the question here is, what's our peak load for heating and cooling? And the one that's the most per zone is going to determine the size of the duct. So in all of our cases right now for these three zones, as far as how we've simulated it, it's all that the cooling load is driving the size of the duct. So the last thing we're going to do is go size the duct itself. So I'm going to look at I'm going to open up this website. If you look in the instructions that I just told you to put in a 0.1 for the friction loss, that you need that. My CFM for zone 1 is 3,300. And you see now we have if the diameter. Oh, wait, let me get rid of this. Sorry. Our duct is about it's if we're getting rectangular duct, it's 19 by 19 inches. And so if we take 19 by 19, 361, that's 361 square inches. You divide it by 144. We've got about 2.5 square feet for that duct. I'm going to put in 2.5 square feet here. Now this is going to be confusing to you, I realize, but if you follow along exactly what I did, you should be able to do it. All that happened here then is we're saying this is the size of my trunk duct for this this zone, and then automatically the branch duct is generated because it's a rule of thumb that that the trunk duct is 80% of the aggregate of all the branch ducts. What that's going to mean then, as you lay out your branch ducts, if you have 2 branch ducts, then their cross section is going to be 1.5 square feet. If you have 3, it's going to be 1 square foot. You just divide it by the number of branches you have. If you don't get that, then we'll just talk about it in class. All I really want you to do is do a layout, and if you don't get this sizing thing, we can go over that in class again. Let me do this one though. The driving, the larger CFM here again is cooling for my gym. It's 11,100. And so now my duct is going to be 30 by 30. So 30 by 30. Divided by 144 to get feet. I'm at 6.25 square feet. That's the size of my trunk duct, and then all of my branch ducts together are going to be 7.5 feet. Let me show you one other thing you can do with this. If I say, it's easier to really, if I'm thinking about my trunk duct right now, and I want it to, I'm like, you know what, I want to just make it 24 inches tall, because I don't want it to be really deep, because you have to put these, above your ceiling or somewhere that's convenient. So I can say, make it 24 wide or tall, and then it will generate my width. So now this means my trunk duct is 2 feet wide by 3 feet, 2 feet deep by 3 feet wide. And that's then what I would draw in that zone. And then I would take branches off of it that then together, if there were 3 branches, they would be 7.5 divided by 3, so 2.5 feet. So if I could make them 2 foot wide by like 2 foot deep. I'm sorry, 2 foot, 1 foot deep by 2 foot wide. Would do that. Um, okay. What else do I need to tell you? So I opened up the assignment. I have gone through all these things. So we did the thermal model. I showed you how to make these changes, well, how to set up the model first, and how to iterate to try to improve your site EUI, your amount of energy the building is estimated to use. Um, then we looked at the duct sizing spreadsheet, which is this, and I ran through that, um, and we came up with some sizing for trunk and branch ducts, and you're supposed to then draw those out, and then using the amount of total, um, so you'd have, if we want to find a piece of equipment for the roof, we have to find something that can deliver this much cooling, this much heating. Um, I know this is a fair amount to ask you to do, so I'm not really that worried about it. The idea was that you would search online to see if you could find just the basic dimensions of something like this. You can also use the rule of thumbs that are in the assignment documentation, or just draw something that's where it should be, and we can look at sizing it later. Um, okay, I think that is all I'm going to say. Um, in summary, don't sweat this too much. Do your best on it that you can, and I definitely assume that we are going to um, need to discuss it and go over it in more detail in class. So good luck, and I'll see you this week.